Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Welcome to Nuclear Pharmacy course in IIUM. Today we will talk about overview of radioactivity. My name is Kamal. In this topic, we will talk about introduction of the nuclear pharmacy, what is an atom, electronic structure, chemical bond, nuclear structure, nomenclature, chart of nuclides, decay of radionuclides, decay of the radioactivity. This content will be divided by 3 sections: video 1, 2, and 3. The introduction of the nuclear pharmacy. So, nuclear pharmacy is a specialty area of pharmacy practice dedicated to the compounding and dispensing of radioactive material for use in the nuclear medicine procedure. Nuclear pharmacy, also known as the radiopharmacy, involves preparation of radioactive material for patient administration that will be used to diagnose and treatment specific diseases in the nuclear medicine. So this is you need to know radiopharmaceutical meaning. Radiopharmaceutical are the radioactive substance or radioactive drug used for diagnostic or therapeutic purpose. According to Bohr atomic theory, an atom is composed of nucleus at the center and one or more electrons rotating the nucleus along different energy orbits. The nucleus is the primary composite of proton and neutron, collectively called a nucleon. For atoms of the given element, the number of electrons moving around the nucleus equals the number of protons, balancing the electrical charge of nucleus. The size of an atom is the order of 10 to the power of minus A, while we call the 1 Armstrong. And that of nucleus is the order of 10 to the power of minus 13, we call 1 Fermi. Well, if you do comparison, the atom nucleus had a diameter about 1 Fermi. That's 100,000 times smaller than size of the atom for the 1 Armstrong. If the nucleus of the atom was a ping pong ball here, the atom should be the size of the football stadium. They are fully of like nothing because of the very small for the nucleus in the atom. But we can know well of the atom theory because of these people. Have a look at an example, the element of lithium. If you look here, the number of proton plus neutron or mass number 7, and atomic number or number proton is 3. Number of proton equal number of electron. So lithium have the electron 3, proton is 3, and neutron is 4. Atomic number doesn't always equal the number of neutron. In the atom concept, you should know electron configuration to determine the chemical properties of an element, and the second is the nuclear structure, characterize the stability and radioactive decay of the nucleus on the atom. Now we discuss about electron configuration or electronic structure of any atom. The Bohr atomic theory states that electrons in atom rotate around the nucleus in discrete energy orbit or cell. This energy cell referred to K, L, M, N cell or so on. These energy cells are stationary and arranged in the order of the increasing energy. Electrons in the highest principal energy level, and they are electrons that sit on the outmost orbit of element, we call the valence electrons. They are responsible for bonding and chemical properties of each element. When there is a transition of electron from the upper orbit to lower orbit, the energy difference between two orbits is released as the proton radiation. If electrons rise from the lower orbit to upper orbit, the energy difference between the two orbits is absorbed and must be supplied for the transition to occur. And emit the proton radiation is our important topic today. According to quantum theory, each cell is designed by a quantum number n, called the principal quantum number, and denoted by integers, for example 1 for K cell, 2 for L cell, 3 for M cell, and so on. Each energy cell by subdivide into subcell or orbital, sp, df, and etc. For the principal quantum number n, there are n orbitals in the main cell. These orbitals are assigned azimuthal quantum number of L. Design the electron angular moment and numerical value of L S orbital L as a 0, as a p orbital L1, d orbital L2, and so forth. For example, K cell 1 orbital for 1s, L cell 2 orbital for 2s and 2p, M cell 3 orbital for 3s, 3p, and 3d. So the other is the magnetic quantum number M, orientation of the electromagnetic moment in the magic field. So the orbital should be S 0, P 1 0 minus 1, D 2 1 0 minus 1 minus 2, and etc. So spin quantum number or S symbol specific an electron rotation about its own axis, S should be negative or positive. Now have a look magnetic quantum number or M symbol. For L0, ML0, this represented the S orbital, so which is spherical in the shape. So when ML0 is the p-z orbital, this is aligned along the z direction having each lobe on either of the origin. ML must be plus minus are the px and py orbital. Ps and py rest on the x and axis. And have a look at this the diagram. Spin quantum number or S symbol. The spin has lockwise or positive or counterclockwise or negative number. Each orbital can accommodate a maximum of a 2L plus 1 electron, and number of electrons is a given shell in the 2n exponents 2. Thus, the K cell can contain only 2 electrons, and next L cell 8 electrons, and M cell 18 electrons, and N cell 32 electrons, and O cell 50 electrons. In atom, the orbital are filled in order increasing energy, that is, the lowest energy orbital is filled in first. This is table illustration, the electron configuration in different orbital and shell. And below, the sample of electron configuration of some element. Now let's move to the other subtopic, the chemical bond. The electronic structure of the atom of the element determines a large degree of the chemical properties of the element. The valence of the elements, tendency of the atom to lose or gain electron to achieve a stable electron configuration. In the primaries, determine that by number of electrons present in the outermost cell, or we call the valence cell. The electron we call the valence electron. Has the electron configuration at S2 and at P6, or we call the octet rule. Like inert elements such as neon, argon, krypton, xenon, except helium 1s2. To achieve stable electron configuration at S2 and P6, electron can be added to or given up from the valence cell through chemical bond formation, or governed by the octet rule. The energy involved in the chemical bond formation, order of the few electron volt, and the electron volt is the energy equal by electron accelerated through the potential difference of 1 volt. The main type of the chemical bond: electrovalent or ionic bond, covalent bond, coordinate covalent bond. We will talk one by one for this type of the bond. First, electrovalent or ionic bond. An electrovalence or ionic bond is formed by complete transfer of an electron from the valence shell of one atom to that of another atom. In ionic bond, two oppositely charged ions are held together in a compound by Coulombic force. For example is the sodium and chlorine. Sodium have the 7 electrons with the valence configuration 3s1 can be donate 1 electron to achieve neon, and chlorine have the 17 electrons 3p5 can be receive 1 electron to achieve argon. The second is the covalent bond. In covalent bond, each of the two atoms participating in the bond formation contribute 1 electron to the bond. Both electrons are shared equal by each atom. The shared electrons are localized in the region between the two atoms, and hence the molecules are non-ionic. The example is the hydrogen, acid chloride, and beryllium chloride. Next is the coordinate covalent bond. In the coordinate covalent bond, the pair of electrons required for the bond formation is donated by only one atom to another that can accommodate 2 electrons in octet formation. These bonds are also called the semipolar bond, because only a partial positive charge is generated on the donor atom and the partial negative charge on the acceptor atom. For the example is the ammonium ion and the hydronium ion. Some donor atoms with a lone pair of electrons can be formed coordinate covalent bond with various metal ions to form metal complexes. Metal complexes are produced by coordinate covalent bonds that are formed by electron donated by the chemical species having a lone pair of electrons. Can be cationic, anionic, and neutral. This is sample of the cationic, ionic, and neutral. The structure of the hexamine cobalt trichloride. Coordinate covalent bond is very important for the radiopharmaceutical. Various radiopharmaceuticals such as the 99M TCDTPA and 99M TC-gluceptate are the complex formed by coordinate covalent bond between 99M TC and the chelating compound. The chelating compound is the DTPA or gluceptate. So this is the structure of 99M TC-DTPA for the renal imaging, and you can see here how to coordinate covalent bond with the DTPA or diethylene triamine pentaacid acid. This is our first video. We will continue our topic for the next video. Thank you very much.